Hello, everyone. Welcome to the mining match. Um, so let's start by mentioning our sponsor. If you are in Latin America or you speak Spanish and you are working in the mining industry, you need to join Hispanomine. Okay, so now I'm going to introduce to our guest speaker. His name is Nigel Fung. He is a mining engineer working for Micron International. We will discuss today about sensing systems in mining. Okay, Nigel, whenever you're ready.
Thanks, Alan. Hello, everyone. Had a small, intimate group today. I'm going to give a short talk just on something that's interesting to me and I'm doing a little bit of research on as a part-time master's at McGill while I'm working at Micron. So sensing systems in mining and their relevance to Industry 4.0, green energy, and mineral security. So the outline of my presentation today is I'm going to be asking what are the sort of the headlining questions. Then I'm going to give a little bit of background on experience with sensors. Then I'm going to be looking at explaining what Industry 4.0 is and talking about it with relevance to the circular economy. Evaluating the value of innovation for mining companies. Looking a bit at circular economy, then talking circular economy, things having to do with sustainability, global demand, green energy, et cetera. Then looking at some specific examples of sensor use in industry in context of 4.0, and then a little bit of a conclusion. So the big questions about sensors, Industry 4.0, and mining are, in the environment of increased demand for sustainability and critical minerals, are the advancement in sensors and Industry 4.0 technologies enough to meet these demands? How does a mining company select what innovation is best for it? Can sensor-based technologies help mining companies compete against global competitors, including protecting themselves from being swallowed up by the Googles, Amazons, or Teslas? And in order to ensure mineral security, do we need new mineral policies and business models if we adopt sensor-based Industry 4.0 technologies? So going back a little bit to my personal experience with sensors and maybe the Internet of Things, perhaps, before I knew what Industry 4.0 was, this was at one of the mines I worked at. We installed some strain monitors and vibration monitors on this crusher because it was starting to fall apart. As you can see in this picture here in the middle, there's a lot of welded bits we put on. Anyways, we communicated the measurements from these sensors through these little black boxes called motes, which hooked into gateways, that gray box in the bottom right-hand corner, and that transmitted the data back to a company in Edmonton. So this is a mine in Mexico, and the crusher was being monitored remotely in Edmonton. We then went and put some humidity sensors, moisture sensors, and pressure sensors right into the base of our leach pad so that we could monitor, exactly the moisture and the compaction in our leach pad. And that cable there that you see in the sort of the middle picture, that's us burying a leaky, basically a leaky feeder wire so that those motes touch those sensors could once again communicate the data back to this company in Edmonton. They were called Scanometrics. And we'd monitor the progress of what parts of the leach pad were getting too much moisture, not enough moisture, where compaction was happening, et cetera. Then we even implemented something called a PI system, process information system, company called OSI Pi, which originally started out servicing the oil industry. And we tried to hook up as much as we can. And I know you can't read these schematics, but basically just You monitor where your data comes from, where it goes to, who uses it, and you try to hook up things to sensors as much as possible or any sort of automatic data generator. And where that's not available, you have people manually enter stuff off of data sheets. Anyways, these are, this kind of evolved into what I think became like the Internet of Things, and then now Industry 4.0. And just on a side note, Industry 4.0 is called Industry 4.0 because it's supposed to be the fourth industrial revolution. The first one being, steam and water power back a couple hundred years ago. Industrial Revolution 2.0 is supposed to be the electrification of everything, and the process line, like in meat packing, then car manufacturing, etc. And then the third revolution was supposed to be around 1960s, when you started having PLCs and sort of feedback loops, or process controls through computers and algorithms. Anyway, Industry 4.0 was created in Germany, and it was sort of basically supposed to drive competitiveness against perhaps China or other countries. And it was going to do this through allowing their factories to be more agile, have better planning, etc., through these technologies like Internet of Things, better cybersecurity, augmented reality, big data, all those catchphrases. And ultimately it was to increase profits and retain customers, really keeping companies relevant in higher and higher competition from other countries. But for mining, it's a little bit different, because often we're dealing with commodities. We don't really have a customer who has a enhanced customer experience from our mining products. So how are we a bit different, or how does this apply to mining a little differently? Well, thinking about it a bit, mining has a lot of pressure from society as a whole for zero waste, zero carbon footprint, all these things. And we're part of a circular economy, so we can kind of think of our customers as being society as a whole, and struggle to meet their needs, but also make them happy with all their increasing demands, and competing against perhaps bad actors who are under the radar, who may not have to meet all these demands. They may not be under the microscope as some bigger companies are. So this wheel here on the right by McKinsey kind of shows some of the levers that Industry 4.0 gives mining. And I've kind of highlighted a few of them to basically, try to meet these demands of the circular economy, green energy, zero footprint. But given all these different technologies, if you're like I am, and I'm sure many of you are, you might receive a lot of advertising or things in LinkedIn just saying, we've got new and better something technology-based, often sensor-based, often, internet integration-based type technologies. How does a mining company evaluate these things? So there's all kinds of systems out there used in the academic papers on. There's things like the Holt Innovation Premium, which Forbes uses to evaluate the world's most innovative companies, which is essentially, I think it's market cap minus future cash flows, which, you could also argue that that's partially goodwill, but there's also RQ, research quotient, like IQ, but for a company. Others evaluate, innovation based on the number of patents issued or revenue from new products, but sometimes these things don't really apply to mining. So it's kind of a big question out there. If somebody can come up with a matrix or an evaluation system to evaluate innovation for mining companies, because every year that passes, the population is growing, our life expectancies are getting longer. We have global fights against poverty, which ultimately just means there's going to be more and more consumers. If we succeed in making everyone a little less poor, everyone will have more money to spend on consumables, all of which take metals. I'm sure a lot of you will have seen these diagrams before, kind of showing increased demand and the quantity of different minerals each person when born will require over their lifetime. Obviously, everybody knows green energy, at least in this small group. I'm probably preaching to the choir. We all know but maybe not everyone knows that all our green energies that we want to see more of and do need rely heavily upon mined materials, mined elements. On top of that, we have new lists of critical minerals that, the government of Ontario and Canada has recently said are critical minerals for, security, green energy security, national security. And the little map on the left is from an EU report showing critical minerals for Europe. And the main talking point there is that none of those black dots are in Europe. They're showing the reliance of EU on minerals from other places. So taking all of that into consideration, how can Industry 4.0 sensor-based technologies help us? One more point here was, this is from Syncrude. It was showing that this is a matrix of what can shut down a mine, and up towards the upper right-hand side is land and biodiversity and water, along with, in that red dot, regulatory and government relations. A lot of things that you don't normally think of as something that you would control or monitor or manage with a sensor-based Internet of Things type technology. At least not in the mining context always, but how can these types of technologies be applied to these things? Only to the lower left do you see things like supply chain, technological development, community investment, those kind of more economic type things. So getting down to sensors themselves, there's all kinds of sensors that are used in mining. I've listed a whole bunch here. And you can probably draw a number of different Venn diagrams here, grouping them together, applying them to things like truck automation or 3D imagery, or wearable safety type instruments. But the list is very large. That's the whole point of this. And so how are these sensors used collectively in mining? So they can be categorized into health and safety, process control, exploration, imaging and mapping, all those different categories along the left side. But the real point of it is that doing a little bit of research into sensors, the sensors themselves are not really the drivers of the innovation, but rather it's their integration with other sensors and other technologies. And in the analytics, using and also taking advantage of the better and faster wireless networks that are now available to move the data from the sensors to the place where they're analyzed using machine learning or AI, what have you. So in the little box up on the right, it's just a quick blurb on automated trucks. One of the main focuses of new sensors and sensor use technologies in automating trucks. So apparently there's 400 to 500 trucks worldwide now, from Caterpillar, and then something like 150 to 200 from Komatsu is what I've been told. And in addition to automation, which is a subtopic of productivity, a lot of the sensor improvements are based in safety. So all kinds of traditional type of sensors, but now a lot of them are mounted onto unmanned aerial vehicles, drones, small airplanes, all that type of thing. And down towards the bottom, one of the hot topics with sensor improvements is that of ore sorting, which uses a number of technologies such as X-ray diffraction. So going back a little bit in the history of sensing systems, back in the old days, you might have had a gauge like seen, and that would have been hooked up to a tank or some other piece of instrument. It could have been a thermometer. And anyways, with the third industrial revolution, these there was ways of collecting electrical data off these sensors and entering them into a system that was hooked to a PLC. Process logic control system. Anyways, these hooked up all these different sources of data via sensors to a network where it could be looked at on a screen, and like in the old days where someone just looked at a gauge, then turned a wrench, somebody might have looked at a screen, run down on the plant floor, turned a wrench, or ran out to a truck and turned a wrench. But, then it kind of got more automated and there was feedback loops. And that eventually became the Internet of Things, where you still have these things with sensors at the bottom of that pyramid, but hooked together to lots of different places where the data could be processed via better networks, Wi-Fi, LTE, G3, G4, now G5. And then those processing platforms then could be viewed or interpreted at some sort of interface, whether that be the company's corporate office, a government, a government agency, or some global marketplace. The key point of this next slide is just that sensors are the basis of the pyramid, which is trying to lead us to new business models, and new business models that will allow, progressive, thoughtful mining companies who care about the sort of demands of society will help them compete in a new way against the mining, competitive mining entities that may not be addressing some of the sustainability issues that are facing the world. A case study of Industry 4.0 being implemented at a mine integrated all these systems listed at the left. And what does that look like in layman's terms is that one example was that sensors that were put on trucks to monitor fuel consumption and tire conditions were integrated real time to the suppliers themselves, so that the mine always had the right amount of fuel available, the right amount of tires, just in time, avoiding shortages. The second example was monitoring the mobile equipment hours and condition monitoring each piece of equipment so that you could better schedule, optimize your maintenance program with your maintenance employees and maintenance equipment. And the third one was hooking smart energy readers onto all electrical consuming pieces of equipment at the mine, so that an algorithm could help minimize the electricity bills. So, given that last case study, the conclusions of looking at all these different sensor-based technologies in mining industry just kind of raises some questions, and it's driving me to do a bit more research and seeing how, for my schoolwork and for my company work, how we can sort of look at what's out there and help mining companies make better decisions, how to basically get the most bang for their buck. And these conclusions can be summarized in automation has proven itself in Australia, Canada, and other regions. So it's going to become more and more prevalent. What does that mean to us? How can we help our fellow mining companies in Canada take advantage of this? Without sensors and sensor-based technologies, it will be difficult for mining companies to meet global demand for minerals. So, we're going to need to continue to advocate for perhaps more government involvement to fund research and help small Canadian research and development companies make advances in these areas. Companies that have a multitude of sensor-based technologies and companies have all these different technologies in front of them, but no real roadmap to success. So, what can be created either in academia or industry to sort of help us to help one another to, use these technologies to our best advantage? Could there be template strategies and guidelines be created for miners to help one another to, basically navigate their way through all these technologies and see what will help us most meet our sustainability responsibilities to our communities and society as a whole. So one thing that I'm trying to work on is an innovation matrix to help industry, evaluate these new innovations that come along. And, without these type of sensor-based technologies, miners face, may face a competitive disadvantage versus, other competitors that may not be taking the full sustainability, green energy, and mineral security issues to heart, and could lead us to losing control on this critical mineral requirements. So that's sort of a quick brief review of sensors, Industry 4.0, and some of the current social issues facing mining. And thank you for listening to my short presentation.
Thank you, Nigel. We're now open for any questions that you may have for Nigel. Anyone can
There's not
unmute their mics. I allow them to unmute the mics.
I have my own questions for myself.
Okay.
In case somebody, and just in case people are thinking of things like for me, one of the big challenges for the mining industry is like, how do you get, like a lot of, in my reading, a lot of things say, your innovation program or your adaptation of innovation is really only as good as your people. And, so you need smart people who can implement these innovations or come up with these innovations. And sometimes mining companies are competing against, Googles and Amazons. So,
Yeah.
If one of those companies is going to pay you, if a mining company is going to pay you $1 and these companies are going to pay you $2, and one wants you to live in San Francisco and the other one wants you to live in, somewhere quite remote and maybe a little bit harsh, how do we tackle that question? And and once we get some of these really amazing systems in place and you have them off in far off places, how do you get people out there to troubleshoot some of these technologies that we'd like to implement? So anyway, just things I think about when I'm going to bed at night.
Yeah. I always also think about how are we going to supply the critical minerals that we need to create renewable energy. Like, for example, producing lithium is quite a challenge, and also a big environmental footprint in this brines that you need to get this critical element to make batteries for all electric cars in the world. It's gonna be, I was reading that it's gonna be like 9 times the demand we have today. So it's a great challenge.
Yeah, I'm not so good at stating all the numbers that I read in magazines and on the internet, but yeah, they really says there is going to be a big demand side drive. So hopefully that bodes well for the mining industry. But I think as Engineering Canada, we hope that we have things sort of ready to take advantage of that, and that we don't, that we can compete at least equally with others globally.
Yeah. Okay.
But yeah, I don't know if this is, I'm assuming this is sort of a hot topic in all countries, and maybe everybody's looking at this and looking at their, whether you're in Chile or.
Yeah, it is. I think it's involve everyone everywhere, because we all are mining consumers. We all need the electronics. We all need appliances and technology. So everyone is connected to mining.
So guys, if I can say something.
Sure.
Yes, go ahead.
You know what? I don't think that it's so scary to start working with all these new technologies. It's scary when you are used to work with new technology and you have to go in a place where they haven't seen anything like automation. So for me, one of the challenges will be how do you get people that are used to live in downtown Toronto or in another big city to go and start living in areas that are a little bit more remote, and they are having their issues, and somehow people don't understand that it's easy to get used to the simple stuff, to the new stuff. It's difficult to go back. So it
Yeah.
does take money to get, to a certain level of optimization, but then it is almost impossible to go back.
Yeah.
That's true. So how I've worked at places where, they wanted to have a little bit of innovation and they want to, but they don't have the big money to make some of the big leaps. So, how do we need more government help for companies to sort of make these advances, or is there some sort of other ways I'm not that smart. I automatically just think, oh, we need government assistance to help mining schools or mining companies to adopt more technologies. Yeah.
I'm thinking that probably some of the people that are selling the equipment and technologies can get a small share of the project and be a partner. If,
Yeah.
otherwise it's one of those things that nobody wants to rely on the government. Everybody wants to see the real result and get money in the pocket.
Right. So I have a question about how sensor systems can contribute to a more sustainable, clean operations in mining sites. Can I provide an example? So just from my career, when we had a leach pad in Mexico, it was obligatory to have wells drilled around it and put sensors in there, constantly monitoring the possibility of cyanide leak through the groundwater. Obviously, there's always been in mines like dust sensors or gas sensors, especially to make sure that you have a safer work environment for employees. Things looking at conditions that might lead to an explosion. For open pits, the ones that are sort of the more traditional ones are things that measure the possibility, like any sort of seismic movements or potential modeling for any sort of a slide in the pit. I think that big pit in Kennecott, Bingham Canyon, I think that was the famous recent one where their sensing systems predicted a large slide before it happened, so they didn't keep anybody working in the pit. So I know that's more safety based rather than clean, but I think a lot of water quality things now. Obviously, with tailings dams, I think there's a lot more sensor applications being applied. Some like in the structures themselves, maybe, but also it seems there's a lot of technologies of imaging, like using photo technology on drones and stuff, like flying over, and they called it, I can't remember what the word is, registering different types of information to the visual images to sort of make these 3D maps, but that also have extra information integrated with the image themselves, so they can track things like movements, cracks, temperature, humidity, those types of things. So anyway, I'm I always feel like I don't know, but
I think sensors are related to monitoring either the water quality, air quality, or also some production. And when you are in open pit mines, for example, you can be monitoring that your level up in the benches or that kind of ore limits or waste limits. So I know that all of that helps to get the job done better. Without all these sensors, we will be blind. Like they give us some guidance, So
Thanks for the questions and thanks for other people answering.
okay, so we're going live on YouTube as well. So I'm going to end the live YouTube and then